Hey guys, today is 6.4 modeling and geometric sequences day 2. So you want to make sure that you're looking at the notes that just has a little bit of information of what we've talked about yesterday so that we could go on for today. Now, I want to revisit the different formulas that we were talking about yesterday. For recursive, remember, you just need to make sure that you find out your common ratio, and then you will put a to the n minus 1. That represents your previous term. When we get to explicit, you have to remember that you're doing the first term times your common ratio, and then n minus 1. That's going to be for your explicit. So let's do recursive first, and then we'll talk about explicit. So looking at number 1, the first thing that we need to do is make sure we find out what the common ratio will be. In order to do that, just like yesterday, all you need to do is hit the second number divided by the first number. So in this particular case, we get 0.25. For every single one of these, they will give us 0.25, but if you want to check, we can. 40 divided by 160, again, gives me 0.25. 10 divided by 40 gives me 0.25, and 2.5 divided by 10 gives me 0.25. That means my constant ratio is going to be 0.25, or I can say 1/4, okay? Once you get that, in order to write your recursive formula, all you're going to do is hit a to the n equals my constant ratio, which is 1/4, times a to the n minus 1. And that's your answer. For the next one, again, we're going to do the same thing. Second number divided by the first number gives me 2.5. Again, you could do it for all of them, but no matter what, it's going to give you the same number. So I have 2.5, or I know it's going to be 5/2. So when I write my recursive formula, it's going to be a to the n equals 5/2 times a to the n minus 1. And that's your answer. For the next one, we have 8 divided by 4, which gives us 2. So 12 divided by 8 gives us 1.5. 16 divided by 12 gives us 1.3. Notice I'm not getting the same number every single time. So for this one, I need to look at what it's doing each time. So how do I go from 4 to 8? 8 minus 4 gives me 4. Let's see if it works for the rest. 12 minus 8, 4. 16 minus 8, 16 minus 12, gives me 4. 20 minus 16, 4. So this means that this is not geometric, it's arithmetic, which is what we talked about yesterday. So you need to remember that when I do this, I'm adding 4 each time. So here, this will be a to the n times a to the n minus 1 plus 4. Because every time, all I'm doing is I'm taking my number and I'm adding 4 to it. So you have to remember that if your numbers are not, and I should have put this here, if you're not multiplying by the same number each time, then that means that it has to be arithmetic, which means that you are adding or subtracting a number in order to get your answer. So when you're adding or subtracting, you have to remember that it's going to be plus 4 or minus whatever number that it's giving you. All right, looking at the next one, I have 51/85. I got 0.6. For the next one, I have 153 over 5, which is this, divided by 51, which gives me 0.6 again. So here I know I am going to have a constant ratio of 0.6. After that, I know that 0.6 is going to be 3 over 5. So that means my recursive formula has to be a to the n 3 over 5 times a to the n minus 1. And that's my answer. All right, for explicit. Explicit kind of works the same way because you still need to find out what your constant ratio is. The only thing that's different about this one is that you will need the first term. So my first term is literally going to be the first term that they give you, which in this case is 29. Now, I just need to figure out what it is that I did in order to get this answer. So I have 58 divided by 29, that gives me 2. 116 divided by 58 gives me 2. But notice that this is a negative number. So in order to go from a positive number to a negative number, that means I needed to multiply by a negative 2. So this is, my constant ratio is negative 2. So that's my R. I also know that 29 is my first term, so that's a of 1. So I'm going to put a of n is equal to, remember you're doing your first term first, so my first term is 29 times my constant ratio, which in this case is negative 2, to the n minus 1, and that's my answer. For the next one, again, I know that my a of 1 is going to have to be 8. Now all I need to do is find out what my R will be. So I'm going to do 16 negative divided by 8 gives me negative 2. 32 divided by 16 negative gives me negative 2. So again, my constant ratio is negative 2. So I'm going to say a of n is equal to my a of 1, which is 8, times my constant ratio, which is negative 2, to the n minus 1. And that's my answer. For the next one, I have 7.8 divided by 2.6, which gives me 3. 23.4 divided by 7.8 gives me 3. So again, I know a of 1 has to be 2.6. I know my R has to be 3 because that's what we got when we were dividing each time. So my formula is a of n is equal to 2.6 times 3 to the n minus 1. And that's my answer. All right, next one. I have a of n, a of 1 is equal to my first term, which is negative 11. So I need to do this. Negative 22 divided by negative 11, which gives me a positive 2. So 44 negative divided by 22 negative, positive 2. So my R has to be positive 2. So I'm going to say a of n has to be equal to negative 11 times 2 to the n minus 1. And that's my answer. So for today's lesson, all you need to do for your assignment is do 2 of your IXLs. The first IXL that you will be doing is writing the expressive geometric sequence, the variables, and then you're going to be writing your formulas in recursive sequence. If you have any questions, please make sure you come by my Zooms in between 11:30 to 12:30 or 2 to 3. Have a good day, guys. Bye.